Hey everyone, welcome back to the deep dive. You know how it is, you want to get up to speed on some complex topic, and today it's Azure Performance Efficiency. You don't want to wade through tons of docs and stuff, right? So think of this as your cheat sheet to Azure Performance Efficiency. We'll give you those key takeaways that'll actually stick.
Exactly. We're all about maximizing your time and giving you those actionable insights. We're going to dive deep into performance efficiency within the Azure Well-Architected Framework and try to uncover some hidden gems, stuff you might not find just skimming the surface.
Love it. All right, so the Azure Well-Architected Framework, some of you might have heard of it. It's basically Microsoft's blueprint for building and running awesome applications on Azure. It came out back in July 2020, and it's designed to help you fine-tune your workloads across 5 main pillars: reliability, security, cost optimization, operational excellence, and, our star of the show today, performance efficiency. Whether you're an architect, a developer, part of the operations crew, or even if you're a business stakeholder who just wants to make sure you're getting the most bang for your buck in Azure, this framework is for you.
Yeah, and it's all about being smart with your choices, right? The framework kind of lays out a set of principles to guide you through those tough decisions when you're designing your architecture. Do you prioritize speed here? Do you prioritize cost there? It also pushes this idea of always trying to improve, always iterating. It's about building that solid technical foundation so your applications not only crush it today, but are ready to adapt and thrive in Azure as it evolves. Because things change fast.
For sure. All right, so let's break it down. Performance efficiency in Azure. What does it actually mean? Well, it's how well your applications can roll with the punches, so to speak. How do they handle changes in demand? Can your system deal with a sudden flood of users without breaking down? Will it scale back down gracefully when things calm down and save you some money on resources? It's about being nimble and tough all at the same time.
That's a great way to put it. It's not just about raw speed, it's about adaptability. A performant workload adjusts smoothly, guaranteeing your users a top-notch experience. It keeps your cloud costs in check by avoiding that whole over-provisioning trap. In the end, it's about squeezing every ounce of value out of your investment in Azure, making sure those resources, compute, memory, storage, everything are working as hard for you as they can.
All right, so how do we actually get there? How do we achieve that performance efficiency in Azure? The well-architected framework hands us 4 core design principles to guide us. First up, we've got negotiate realistic performance targets. It sounds simple enough, but there's more to it than just saying, hey, I want this to be fast.
Yeah, that's where it gets interesting. It's not about pulling targets out of a hat. It's about really digging into your workload, figuring out what it needs to perform at its best. Setting goals that are ambitious, sure, but also achievable and tied directly to your business goals and the experience you want your users to have. To do that, you need clear, measurable benchmarks. And this is super important. Talk to your business folks, understand the level of service you've promised, and any regulatory hoops you need to jump through.
Right, so it's not just about how fast a web page loads. It's about the whole journey, the user experience. Like, how quickly should things respond when a user clicks something? How fast does data need to flow between different parts of the system? What about all those background processes humming away behind the scenes? You need to consider all this, how often people use your app, the costs, the operational side of things, and how vital this workload is to your business. All that goes into creating a holistic performance model.
Exactly. And it's not just about what your system does, it's also about how it does it. Think about performance, security, reliability. All those things matter. And you need to understand how they all play together, sometimes even competing with each other, across all those pillars of the well-architected framework. That's how you make smart design decisions.
Got it. Okay, so principle number 2, design to meet capacity requirements. Now we're looking into the future a bit, right? Planning for what's to come.
If you zoom out, yeah. It's about making sure your systems can handle the load today, but also any growth that's coming down the road. You have to make sure you have enough resources ready to meet that demand. And that means being proactive, measuring your system's performance, setting baselines so you know what normal looks like, and spotting those potential bottlenecks that could hold you back.
So it's about picking the right tools for the job, right? Choosing the right Azure services and configurations across your whole tech stack, making sure they meet your current performance needs, but also work well together and can scale up when you need them to. And of course, there's always that unpredictable spike in traffic. How do you handle that?
That's where things get really tricky. You need to balance your resources with the actual demands on your system. And you really want to avoid over-provisioning, because that's just throwing money away. Azure's auto-scaling features are a lifesaver here. They can automatically adjust your resources based on the demand patterns you've identified in your performance model. It's interesting, though, a lot of companies are hesitant to go all in on aggressive auto-scaling. They're worried about costs spiraling out of control. But that rarely happens if you set up those thresholds right. And actually, we've seen that companies that hold back on auto-scaling often end up overpaying for their compute resources by something like 20%.
Wow, that's a big difference. All right, let's move on to principle number 3, achieve and sustain performance. I guess it's not just about hitting your performance targets on day one, right?
You're right. It's more than just a launch day celebration. The real question is, how do you keep that performance humming along over the long haul? You have to build systems that can hit those initial goals and then stay there consistently. Again, it comes down to being proactive, measuring, setting those baselines, and anticipating the challenges that might pop up down the road.
And that's where predictive modeling comes in, right? It sounds fancy, but it makes sense. You're trying to forecast when you might need more capacity, whether it's because of seasonal spikes or just steady growth. And then you need to translate those big picture performance goals into actual concrete requirements that your devs can work with.
Absolutely. And don't forget about the money. You need to understand what it's going to cost to hit those targets and keep hitting them. Documenting your performance testing strategy is crucial too. What exactly are you testing? What methods are you using? How often are you testing? And then you need processes, workflows based on that test plan, focusing on the tests that tell you the most about whether you're on target and if your capacity planning is on point.
Okay, last but not least, principle number 4, improve efficiency through optimization. This sounds like the part where we're always tweaking, always looking for ways to do things better, right?
That's the heart of it. It's about having a mindset of continuous improvement. Without a plan, you might fall into the trap of just throwing more resources at a problem. But that defeats the whole purpose of the cloud. You got to understand how your design choices affect performance and cultivate a mindset in your team where they're always looking for ways to use resources more efficiently and eliminate waste.
I like that. All right, so we've got the core principles down. Now let's get practical. How do we actually set those performance targets in Azure and then make sure we hit them? It's got to be more than just hoping for the best, right?
Definitely not.
Yeah.
It starts with those measurable targets we talked about, the ones tied to your business goals and what you want your users to experience. It's not just about the tech. You've got to get your business and tech folks working together on this. In the end, it's about how those targets affect your business. Are your users happy? Are you meeting your SLAs? Those are the real measures of success.
Yeah, those are the things that really matter. And then you've got to pick the right Azure services to help you hit those targets. It's a big decision. There are so many options.
There are so many choices, and picking the right ones is key. It's about selecting the right tools across your entire tech stack, the ones that'll help you hit your performance goals and work well with your existing systems. For example, if you're running web applications and don't want the hassle of managing VMs, Azure App Service in the P1 v3 tier is often a good sweet spot for performance and cost. Think of the P1 v3 tier as offering a solid amount of dedicated compute and memory, which fits nicely with our design to meet capacity requirements principle without jumping to those pricier options right away. Then for microservices that need to scale like crazy, Azure Kubernetes Service, maybe using Burstal B-Series or D-Series VMs for its nodes, could be the answer.
What about those applications that are triggered by events?
For those event-driven workloads, Azure Functions in the consumption plan can be super cost-effective. You only pay when your code actually runs. Kind of like, you only pay for electricity when you turn on a light. If you need more control and want to build your workloads on custom VMs, D-Series or E-Series, Azure VMs are popular choices. They offer good balance between performance and cost. For relational databases that need auto-scaling and cost optimization, Azure SQL Database in the serverless or DTU model is a good fit. And if you're working with NoSQL and need high availability and automatic scaling, Azure Cosmos DB in its auto-scale mode is usually the way to go.
It's great to have that rundown of recommended services and tiers, but it also highlights that the best choice really depends on what your workload is actually doing. It makes sense. There's no one-size-fits-all solution in tech. So once you've got your services lined up, what's next?
Capacity planning is next. You got to think ahead and figure out how many resources you're going to need under different loads. And I don't just mean the average load. I mean those peak times too. You got to be ready for anything. And to do that, you need solid data. So collecting performance data constantly is super important. You got to keep tabs on your system, gather those key metrics, and spot those potential bottlenecks that could trip you up. That's where that performance model we talk about comes in handy. Understanding how people use your app, the costs involved, and how important this workload is to your business will help you use your resources wisely and plan for the future.
Okay, so targets are set, services are picked. Now let's talk about making things more efficient. Scaling and partitioning seem to be key parts of this, right?
They're huge. Scaling, either vertical, which is adding more power to what you already have, or horizontal, which is adding more instances based on demand, it's essential in the cloud. Horizontal scaling is especially cool because it's so elastic. Think of it like this. Vertical scaling is making your single pizza bigger, while horizontal scaling is like getting more pizzas. You can add or remove instances as you need them, making your system more resilient and saving you money by shutting down extra capacity when things are quiet.
And Azure makes it easy, right? It has auto-scaling features built right in, so that's usually the first thing we should be looking at.
Absolutely. Before you go off building some complex custom scaling solution, check out what Azure already offers. And then there's partitioning, where you break down your workload or data into smaller, more manageable pieces. You can do it horizontally by splitting data across rows, vertically by splitting it across columns, or functionally by separating different parts of your application. Partitioning is crucial for performance and makes scaling a lot smoother.
So how does Azure VM auto-scaling work with virtual machine scale sets? What does that look like in action?
With virtual machine scale sets, you can create a group of identical VMs that are load balanced and can adjust their numbers automatically based on things like workload, specific performance metrics you set, or even a schedule. When things get busy, VMSS scales out by adding more VMs. When things calm down, it scales in by removing them. And to avoid those rapid back and forth changes that could mess things up, there's usually a cooldown period between scaling events.
That makes a lot of sense. So it's not just about throwing more resources at a problem, is it? You also have to look at your application code and how your infrastructure is set up.
You nailed it. Efficiency has to be baked into your code and your infrastructure. Consider using asynchronous programming so your application isn't just sitting there waiting for things to finish. Caching frequently accessed data can drastically reduce latency and make things feel snappier. And optimizing your database queries is super important. Make sure they're well written and that your databases have the right indexes. I can't tell you how many times I've seen a seemingly simple page load take forever because of bad database queries.
It's a classic mistake for sure. And what about offloading certain tasks? Can that help?
For sure. If you have tasks that are resource intensive, especially background tasks that don't need to block the main user flow, think about moving them to serverless compute options like Azure Functions. And for serving up static content like images and CSS files, Azure Front Door is a great way to go. When you're designing web APIs, shoot for platform independence, make sure they can evolve over time, and focus on efficiency, responsiveness, scalability, availability, and make sure you have good error handling. Oh, and try to keep the amount of data that needs to be transferred over the network as small as possible.
All right, so efficient data storage, retrieval, and processing, it sounds like another area where we can make a big impact on performance.
It's absolutely critical. Handling data efficiently is essential for good performance. For databases, this means rewriting complex queries to make them run faster, avoiding the N+1 query problem by using joins and batch fetching effectively, being smart about the order you perform joins, using index hints where appropriate, caching those frequently used query results in memory, optimizing your locking mechanisms, and constantly monitoring and tuning query performance.
Okay, and how about those database indexes themselves? How do we make sure they're helping and not hurting performance?
Optimizing those indexes is a constant battle. You got to analyze your application's query patterns, figure out which data fields are used the most for searching and filtering. Then you need to look at your existing indexes. Are there any redundant ones you can get rid of? Are some being ignored? Figure out which columns need indexes, what type of index works best for your queries, and think about the order of columns in composite indexes. Keep an eye on the size of your indexes and make sure you're maintaining them, monitoring them, and defragmenting them regularly.
Now, with Azure Block Storage, we have those different access tiers: hot, cool, and archive. How do we choose the right one?
Intelligent tiering is a great way to optimize costs and performance for your blobs. If you access data frequently, the hot tier is the way to go. For less frequently accessed data, the cool tier is more cost-effective. And for data you hardly ever need but got to keep around for a long time, the archive tier is the cheapest option. Azure lets you automate moving data between these tiers based on access patterns using blob storage lifecycle management policies. And for relational databases, Azure SQL Elastic Pools help you manage resources for multiple databases efficiently. If you have demanding performance requirements, Azure SQL Hyperscale can provide that dynamic scaling you need. And no matter how you store and retrieve data, the key is to keep monitoring query performance and optimizing those indexes.
Okay, let's talk about focusing on critical performance flows. What does that mean practically?
It's about figuring out which parts of your workload are most sensitive to performance issues, the user interactions or back-end processes that really impact the overall user experience or your core business operations. Prioritize optimizing those key user flows above everything else. And at the same time, try to streamline your routine operational tasks. Automation is your friend here. Automate things like deployments, backups, responses to common monitoring alerts, anything you can. It'll reduce manual work, cut down on errors, and free up resources for performance optimization. The operational excellence pillar of the well-architected framework really stresses the importance of automation.
And this isn't a one and done kind of thing, right? Performance optimization is an ongoing process.
Absolutely, it never really ends. You got to regularly optimize those databases, look at your queries, indexes, data models, and configurations. Bake performance optimization into your development lifecycle, test constantly, and once your app is live, keep monitoring it to understand how healthy it is and find areas where you can make things even better. And based on what you learn from monitoring, refine those performance test scripts to make sure they're still relevant and doing their job.
Okay, so we've built our system. Hopefully it's efficient. How do we make sure it stays that way over time? I'm thinking testing and monitoring are super important here.
You got it. Testing is your way of making sure your application can handle the load and stay stable under pressure. There are a few key testing methods. Load testing, which simulates typical user traffic. Stress testing, which pushes your system to its limits to see where it breaks. Soak testing, which checks how your system performs under sustained load over long periods. And breakpoint testing, which tries to find the maximum load your system can handle before it starts to fall apart. When you're running these tests, you need to define realistic user personas and mimic how real users interact with your app, including things like think times and variations in load, and always set clear benchmarks so you can track your progress.
Now, Azure has a dedicated service for this, right? Azure Load Testing.
Yep. Azure Load Testing is a fully managed service that helps you generate realistic load and pinpoint bottlenecks. You can simulate traffic from thousands of concurrent users and even import your existing Apache JMeter scripts. It gives you real-time monitoring of key performance metrics, all integrated with Azure Monitor. And you get tons of data and insights that help you identify those slow parts of your application and fine-tune your scaling. You can even build it into your CI/CD pipelines, like Azure DevOps or GitHub Actions, to automate your testing and set thresholds to prevent performance regressions.
And to monitor our production environments and make sure everything's running smoothly, we have Azure Monitor and Application Insights.
Those are your go-to tools for getting a deep understanding of how your Azure applications and infrastructure are performing. Azure Monitor is a comprehensive monitoring service. It gathers data from your apps, operating systems, and various Azure services, giving you one place to see how everything's doing. Application Insights is part of Azure Monitor. It's focused on application performance management, giving you detailed insights, automatically detecting anomalies, and tracking key metrics. Then there's Log Analytics for collecting and analyzing logs, and Azure Metrics for getting numerical data on performance and resource use. When you're setting up your monitoring strategy, you need to figure out what you want to monitor, how long you want to keep the data, and set up alerts so you know if there are any problems. And the cool thing is Azure Monitor can even pull in data from both your Azure and on-premises environments.
All right, so we've talked a lot about performance efficiency, but it doesn't exist in a vacuum, right? How does it relate to the other pillars of the well-architected framework, like cost optimization and reliability?
That's a great question. Performance efficiency and cost optimization go hand in hand a lot of the time. Optimizing for performance, like by using autoscaling and right-sizing your resources, can often save you money because you're not wasting resources. But, and this is important, sometimes there are trade-offs. If you try to cut costs by aggressively scaling down, you might end up hurting performance when you get those sudden spikes in demand. On the other hand, spending more on high-performance resources might cost more upfront, but it could save you money in the long run because everything runs more efficiently. So the key takeaway here is to keep an eye on both your performance and your costs to find the sweet spot.
Makes sense. Now, how about performance efficiency and reliability? How do those two work together?
Well, features like redundancy and failover mechanisms are crucial for making sure your system is always available. But these reliability measures sometimes come with a bit of a performance cost, like the latency you get from replicating data across multiple zones. But a well-designed, reliable application can actually contribute to better overall performance because there's less downtime. And things like horizontal scaling, which we often use to boost performance and handle heavy loads, can also make your system more reliable because the workload is spread across multiple instances. So you need to find the right balance between reliability and performance and keep an eye on how those reliability measures affect performance, like how often failovers happen and how long they take.
Okay, so let's look at some real-world examples. We've got a few case studies that show how this all works in practice, right?
Yes, we do. One company, a manufacturer, moved their critical workloads to Azure SQL Managed Instance, upgraded their hardware, and started using autoscaling. They managed to slash their database costs by a whopping 60% and cut their average transaction processing time from 5 seconds down to just 2 seconds.
That's huge. What else have we got?
There was an e-commerce platform that used Azure Front Door for content delivery and added dynamic scaling. Their page load times improved by 40%. They saved $10,000 a month, and they managed to maintain 99.99% uptime even during their busiest periods. Then there was a company that provides medical imaging systems. They started using Azure DevOps for their development and deployment processes and ended up with a 50% increase in their overall workload capacity, a 25% reduction in administrative overhead, 40% fewer manual interventions, and saved an estimated $150,000 per year. And finally, a fintech leader worked with a cloud optimization service that used the principles of the Well-Architected Framework to cut their total Azure costs by 12%, while also improving their operational efficiency by right-sizing and optimizing their licenses.
Those are some seriously impressive results. So what are the key lessons we can take away from these real-world examples?
A few things stand out. Picking the right Azure services, especially managed services that handle the heavy lifting for you, is really important. Implementing autoscaling well is almost always a win for both performance and cost. Continuously optimizing your resources, monitoring them, and making sure they're the right size for the job makes a big difference. Using CDNs like Azure Front Door is super effective for making applications faster and improving user experience. Proactive monitoring and ongoing management are crucial for catching problems before they become big headaches. And, maybe the most important lesson of all, following the principles and best practices of the Well-Architected Framework gives you a solid foundation for success in the cloud, not just for performance, but for everything.
So as we wrap up our deep dive today, it's clear that achieving great Azure performance efficiency is a constant process, right? It's not a one-time thing. It takes a good understanding of the well-architected framework and a smart ongoing use of Azure services and best practices.
Exactly. It's a journey. It starts with setting realistic, business-focused performance targets, then designing your system to handle the expected load, making sure it hits those targets and stays there, and then embracing this idea of continuous improvement, always tweaking and refining things to get the best possible performance.
We've covered a lot of ground today, from different ways to scale your systems and optimize your application code and infrastructure, to efficient data management techniques and the importance of services like autoscaling, Azure Cache for Redis, and Azure CDN.
And remember, those architectural patterns we talked about, they can be incredibly helpful. Plus, there are specific optimization techniques you can apply to your compute, storage, network, and database resources. Those can make a big difference.
And we can't forget about testing. Comprehensive testing and robust monitoring are essential for making sure your Azure workloads stay healthy and performant.
For sure. And it all comes down to finding that balance between performance efficiency and those other pillars of the well-architected framework, like cost optimization and reliability. That's how you succeed in the cloud. Those case studies we looked at show just how much of a difference it makes when you focus on performance efficiency. We saw significant cost reductions, apps that were noticeably faster, systems that could handle much heavier loads, and overall improvements in operational efficiency.
So as you continue your own Azure adventures, think about this. How can you create a culture of continuous performance optimization within your teams and your organization? Could that kind of proactive approach give you a competitive edge and create amazing experiences for your users? Maybe it's time for you to take a deeper dive into the Azure Well-Architected Framework and see how you can apply these principles and strategies in your own Azure environment. Thanks for joining us on this deep dive.